Hi there students, welcome to lesson 1 on the topic of quadratic equations and their graphs. Let's get started. What is a quadratic equation? Well, a quadratic equation is any mathematical equation of this form here. Y equals ax squared plus bx plus c. Now, x and y are the variables in the equation. Now what that means is, when we draw graphs of these equations, the vertical axis will be labelled with y. Y is the dependent variable. The horizontal axis will be labelled with x. X is the independent variable. So, in this equation here, x and y are the variables in the equation. What are a, b and c? A, b and c are fixed number values or constants. So what it means is, any particular quadratic equation will have its own unique set of a, b, c values. Now, what number values can a, b and c assume or take on? Well, the answer is any number values at all. A, b and c can be any number values at all. They can be positive whole numbers, they can be negative whole numbers, they can be fractions or decimals. There is, however, just one exception to that. A, b and c can be any number values at all, except a is not allowed to be 0. The reason for that is quadratic equations must contain x squared. And if a was allowed to be 0, we would have 0 multiplied by x squared. 0 multiplied by x squared is 0. Which means the x squared term would disappear altogether, and the equation would not contain x squared. Therefore, it would not be a quadratic equation. So, a, b and c can be any number values at all, except a is not allowed to be 0. B and c can be 0. So what that's saying is, if b and c can be 0, it means that a quadratic equation doesn't have to contain x, and it doesn't have to contain a single number value or constant value at the end of the quadratic equation. If b was equal to 0, which b is allowed to be 0, if b was equal to 0, we'd have 0 times x, which is 0, meaning the x term would disappear, and the quadratic equation would not contain x. That's okay. A quadratic equation doesn't have to contain x. It's allowed to, but it doesn't have to. The same sort of thing applies for c. If the c value is 0, well, if the c value is 0, the quadratic equation won't contain a single number value or constant value at the end of the quadratic equation. So this is the best way to think of quadratic equations. They are equations which must contain x squared. On top of that, they are also allowed to contain x and or a single number value at the end of the quadratic equation, but they don't have to contain either or both of those things. They must contain x squared. They are also allowed to contain x and or a single number value or constant value at the end of the quadratic equation, but they don't have to, but they must contain x squared. Let's go ahead and do some questions on the board. Question. Write the quadratic equations which have the following a, b, c values. First one, quadratic equation with an a value of 3, b value of -2, a c value of -1. We go back to this, we replace a with 3, b with -2, and c with -1. This is what we get. Y equals 3x squared, replacing a with 3. Now we're going to replace b with -2, so that'll be minus 2x. And we're replacing c with -1. So plus -1, plus -1 is the same as subtract 1. So minus 1. So that's the first quadratic equation. On to question 2. What if we have a quadratic equation with an a value of -1, a b value of 0, and a c value of 3? Well, let's go back to this and replace a, b and c with the values given here. What do we get? Y equals, instead of a we've got -1, -1x squared Instead of b we've got 0, so plus 0x. Instead of c we've got 3, so plus 3. Now, let's just do one more step of working out here. Y equals, now, 1x squared means 1 multiplied by x squared, which is just the same as x squared. So we can write negative 1x squared as just negative x squared. Negative x squared. Now, 0x means 0 multiplied by x, which is 0, which means the x term disappears. So that disappears. This quadratic equation will not contain an x term. It will, however, contain plus 3 at the end. So just plus 3. That's the answer for that one. Y equals negative x squared plus 3. On to question 3. If we have an a value of negative 4, b value of 1 and a c value of 0, what do we have? Y equals negative 4x squared plus 1x plus 0. Let's just do one more line of working out. Y equals negative 4x squared. Now, 1x means 1 multiplied by x. 1 multiplied by x, well, 1 multiplied by 7 is 7, isn't it? 1 multiplied by 13 is 13. 1 multiplied by x is just x. So, plus 1x, we'll just write it as x. And plus 0, we can just leave that out. That's the final answer there for that one. Okay, on to question 4. What if we have an a value of 1, a b value of 0 and a c value of 0? Just a reminder, a is never allowed to be equal to 0. B and c, however, can be equal to 0. B and or c can be equal to 0. What do we get here? Y equals 1x squared plus 0x plus 0. One more line of working out. 1x squared is just the same as x squared. 0x is just 0, so the x term disappears, and plus 0, we don't need to write that. So that's the answer there for that one, y equals x squared. Quick recap, let's just check these 4 answers we have on the board. Note, each answer contains x squared, doesn't it? X squared, x squared, x squared, x squared. Some of them also contain x and or a single fixed number value at the end of the quadratic equation, but they don't have to contain those two things. They must contain x squared. They're allowed to contain x and or a single number value at the end of the quadratic equation, but they don't have to. Now, let's talk about the graphs of quadratic equations. The graphs of quadratic equations. Graphs of quadratic equations are curves, they are not straight lines. Okay? The graph of any quadratic equation will be a smooth curve called a parabola. That's that word there, parabola. So heading here, graphs of quadratic equations. Smooth curves called parabolas. And the good news is this. For graphs of quadratic equations, there are only two possible general shapes for the graphs of quadratic equations, and I've got them on the board. Okay, the first possible general shape is this one here. We call that an upright parabola. You could call it a smiley face curve. The second possible general shape is this one here. That's called an inverted parabola. You could call that a sad face curve. Now, what determines which of these two general shapes we end up getting? Well, the answer is this. The general shape of the quadratic equation graph is determined by the sign of the a value in the quadratic equation. Remember, the a value is the number directly in front of x squared in the quadratic equation. if the a value in the quadratic equation is positive, that is, if the sign of the a value is positive, or if a is any positive number, the sort of graph you'll get is an upright parabola. If the a value is any negative number, in other words, if the a value is negative, the sort of graph you'll get is an inverted parabola, like that. So they're the two possible general shapes. There's only two possible general shapes for the graphs of quadratic equations: an upright parabola or an inverted parabola. Now, I say general shapes because the width of those parabolic curves does vary. And what is it that determines the width of the parabolic curves? Well, the answer to that question is the width of the parabolic curves is determined by the size or the magnitude of the a value. So it's all got to do with the a value, all right? The sign of the a value determines which general shape it is: upright parabola or inverted parabola. The size or the magnitude, and when I say the size and the magnitude, I just mean the number part of the a value, ignoring whether it's positive or negative. The size or the magnitude of the a value determines the width of the quadratic equation curve, or the width of the parabola. And the way it works is this: the bigger or the larger the size of the a value, the skinnier the parabola graph becomes. So with the 4 questions we have on the board, if we did graphs of those 4 quadratic equations, the skinniest one would be question 3, because its a value is -4. Remember, when we're considering the effect on the width of the graph, we ignore the sign. We just look at the number part. Okay, 4 is the highest magnitude a value, or the highest size a value, ignoring the fact that it's negative. Right? So the skinniest graph, or the skinniest parabola curve out of the 4 questions we've done on the board there, would be this one here. Let's quickly go through questions 1, 2, 3 and 4 and decide which of the two possible general shapes the graph would be. Okay, question 1, the a value is positive, so it would be an upright parabola. Question 2, the a value is negative, so it would be an inverted parabola. Question 3, the a value is negative, so it would be an inverted parabola. But as I said, okay, because the size of the a value there is the highest out of these 4 questions, this parabola curve would be the skinniest one. Question 4, the a value is positive, so it would be an upright parabola. Okay, so that concludes lesson 1 on the topic of quadratic equations and their graphs. Thanks for watching. Look out and stay tuned for subsequent lessons on this topic of quadratic equations and their graphs. Thanks for watching. See you next time.